Okay, we're on number 3. Now, this one introduces a new concept on functions that we've not yet visited in class. However, it's a very simple concept. It's talking about equations that represent a nonlinear function again. So this is about identification of functions and whether or not they make a straight line. So a nonlinear function, again, can create a shape that maybe curves, or maybe it would be a parabola shape, something like this. And if you recall, a nonlinear function, or a non-function rather, will fail the vertical line test. And this is one of those examples that fails the vertical line test. So sometimes a nonlinear function is not a function. Other times, like this one, it would follow the vertical line test. It's okay, but it's nonlinear. So we're trying to figure out which of these equations represents a nonlinear function. In other words, it's not a straight line. Now here's the easy part to it. If you see any exponents in a function or an equation such as 3x squared here, it is a dead giveaway that it is a non-linear function. Now I can get into a whole lot of explanation and show why that's going to become a parabola and on the graph, and it's going to be hour-long video. However, let's save it for class when we're all together and we can look at this. So the question here also says select all. So there's more than one answer. That's going to be suggested in this. So dead giveaway, letter A right here is a nonlinear function because it has that exponent, 3x squared. That's the giveaway. So if we see anything else that's going to produce an exponent of x squared, it's nonlinear, okay? So in the second one, letter B, y equals 3x minus 10. Well, we recognize that as our y equals mx plus b, our slope-intercept format. So we have y equals mx plus b right here, y equals 3x minus 10. So that is a linear equation. If you remember that from class, that would create a straight line. So don't circle that one. That one's okay. How about this one? We have y equals 2x plus 9 plus x. Well, they're trying to throw you a curveball on this one, but I'm going to show you why it's okay. If we have y equals 2x plus 9 plus x, well, we have like terms, our x and x terms. So if we add these together, it's going to come out to the same format as y equals mx plus b. And I'll show you why that is very quickly here. If we just go to 2x plus x, that will give us y equals 3x plus 9. And there it is. It looks just like y equals mx plus b. So that is a linear function. It's okay. We can leave that one alone. Now, our next one, we have y equals x times the quantity, parentheses, 3x plus 10. Now this is going to give us something else to work with here. If we have y equals x times 3x plus 10, well, what happens when we multiply x times x? If we do the distribution property to this and multiply everything inside the parentheses with the variable outside the parentheses, we're going to get y equals x times 3x. Well, that's going to give us 3x squared. There's x times x right there. And then, of course, if we finish, we have plus 10x. Well, there's our exponent. That's going to give us a non-linear function. That's that dead giveaway. So circle letter D also. So for our answers so far, we should have letter D and letter A. And I didn't mean to get everything there. We should have letter D and letter A as our possible answers, okay? Now, letter E gives us y equals x over 3 plus 10. Well, if you recall, again, y equals mx plus b, our slope-intercept form, it is perfectly fine to have a fraction in our mx plus b. So I'm going to rewrite this just so that it looks a little bit more familiar to our mx plus b. Y equals x over 3 plus 10. That x over 3 is the same as saying 1 over 3x plus 10. So that's our mx term right there. That is a linear function. The m is 1 over 3. That's our slope, rise over run. So that's totally fine. Letter E is a linear function. So you should have as your answer letter A and letter D. Those are non-linear functions.